mute everybody in the meeting, hopefully except me. Can you hear me? Good.
Yeah, I've just unmuted myself, Simon. So
yeah,
where have you gone?
good.
There you go. Yeah. So just
And
obviously everybody knows Simon's, but if you don't, Simon Allerton from the University of Aberdeen and Mid-Grampian Mesolithic. And he's going to talk about after the ice, geological evolution of the River Dee. And you'll find out why, although he's involved with the Don, he's talking about the Dee. But I'll leave it to you, Simon, now, and see you at the end.
yeah, okay. So yes, after the ice, geological evolution of the River Dee. So basically the geology of the Dee after the ice has retreated, which I think has the focus of this talk will be heavily on the geological aspect, but I hope it'll be of interest to an archaeological group because it's essentially laying the foundations for the sort of the paleo environmental conditions for that period of the late Paleolithic and Mesolithic in the area. So the outline of the talk, I'm going to first of all briefly talk about the timing of glacial retreat, and then spend a little time just talking about the sort of the sediments and landforms that we have associated with the deglaciation. And then talk some about terrace mapping and a model for the terrace formation, particularly of the glacial terraces. And then briefly talk about the Meander terraces and the modern processes affecting the river, before finishing off really on the timing of the terrace formation and how that fits in with the evidence for people living in Deeside. As you're all well aware, the Dee starts in the high Cairngorms on the foothills or around Brearach, the third highest mountain in Britain, and descends down through a sort of a mountainous environment until it gets down to the lowland area below Banchory of northeast Scotland. So quite a range of environments within that frame. The work that I've been doing has focused on the LiDAR data. LiDAR is it's an airborne survey tool using lasers to map the topography and generate a very high resolution topographic image of the surface, which they can also use to get rid of the effects of trees and things like that. So it's a very powerful tool for doing geomorphology. And the river itself, as you're all aware, sort of changes in its character as it goes along, and you have various places with open reaches of really quite broad areas, like the one here shown around Pothach, but you have them around Ballater and Braemar as well, and around Aboyne, and other places where the river is really quite tightly constricted, for instance, around the Linn of Dee, but also around Cambus-on-May and around Pothach itself. And in those places, you actually get the bedrock exposed at the seabed, in the riverbed. We also talk about the timing of the glacial retreat here. This is from the extensive study by Clark et al. Of the Brit Ice project, and it's sort of showing the basically the retreat. The last glacial maximum was somewhere between 25 and 20,000 years ago, and the ice has retreated from northeast Scotland up into the mountains between then and about 15,000 years ago, between about 20 and 15,000 years ago. And we got evidence, for example, that Pitfickie was exposed. The ice came off the top of Pitfickie at about 19,000 years ago. Following the regional deglaciation, we go into the late last glacial interstadial, the Windermere interstadial, which is where we see our late Upper Paleolithic people occupying the area. Following that, we have a brief cold period of the Younger Dryas that only really gets seen in the northern hemisphere and is believed to be related to the draining of Lake Agassiz in America, which upset the Gulf Stream and causing significant cooling in northeast Scotland, or in Scotland in the northern hemisphere. But in northeast Scotland, we see it as being a very dry, cold period. We don't think that there's glaciation associated with that. In west of Scotland, that's the time of the Loch Lomond re-advance. So it's you get more precipitation in the west and glaciers formed there. But in the Cairngorms, probably glaciers at the top of the hills, but not in the valleys at that time. Following the Younger Dryas, we go into the Holocene and Mesolithic period, where we see a very rapid improvement in the climate. And along with that, we see increased vegetation and also the starts of evidence from Mesolithic period people occupying the sites that we have along Deeside at Chest of Dee, Nether Mills, Mill Timber, and so on. I've also included in the just down here, I hope you can see my mouse, an example of a glacial meltwater river from Iceland, from Gullfoss in Iceland, just to emphasize the fact that whilst that basically during this regional deglaciation period, the rivers would have been much more active and have much higher flow rates and be much more capable of erosion and deposition than we see in the current Dee. So think of Storm Frank on steroids for the sorts of conditions that we might have had at the time. Oh, number 2. So start talking a little bit about the glacial landscapes that we see. One of the key elements of this is the glacial till, which is draped over most of the lowland areas of northeast Scotland. So glacial till is a sort of it's a mix of clay and silt matrix with lumps of rock lodged within it. It's matrix supported, and it basically formed either by material melting out at the base of the glacier or rock underneath the glacier being deformed and creating this mess of sediment associated with it. What you see along with that are these really quite distinctive landscapes of very smooth topographies, undulating topographies with elongate ridges associated with them. So you can see on the map around here where you have these approximately east-west running ridges that are basically carved as the ice has moved over the landscape. You also see at the tops of the hills much more irregular terrain, and in those places the bedrock has actually been exposed, and these are crag and tail features, so that the ice has gone over the hill, exposing bedrock at the top and dumping the glacial till behind it. But this sort of terrain creates these smooth topographies over much of northeast Scotland. They also, as a result of that, it creates a sort of egg box style topography where you've got the high hills with bare rock exposed at the top, and then smooth slopes, and then lows which would have been carved out by the glaciers, which are now filled. These would have originally been glacial lakes and boggy areas, mosses, as they often are now, but they're largely now flat-based areas within that sort of undulating topography. And you can see that they're actually make up a very large proportion of the area between the Dee and the Don. A lot of these features. Evidence for them that you can see, look for evidence for them on the historic maps, but that only goes back so far. But there's actually a really good evidence for the existence of these things provided by the mapping from the British Geological Survey, who did quite an extensive job of mapping out the various glacial sediments back in the 70s and 80s. So a lot of boreholes sitting out there, which often record these sorts of lacustrine sediments and peats and things associated with them. So obviously the lacustrine sediments forming within the lochs themselves, and the peats beginning to form once those lochs have silted up, and you're beginning to get sort of moss areas and swampy, boggy areas. But probably very important environments for people living around at that time. So this would have been happening right through the Holocene as these things, through the Mesolithic, basically, as these things silted up and filled. We also see some really interesting characteristic features just along the edge of the River Dee. These sort of ice marginal or potentially subglacial channels. They're characterized as being oblique to the slope, so they don't flow straight downhill like a normal river would. They're flowing down the slope, and they often form these sort of stacked patterns of slightly offset from each other, marking the place where the glacier retreated slightly, so that basically you had streams running along the edge of the glacier. The glacier would retreat some, and then you'd have the stream moving position down to the side. These things are often dry in the current state, but they're probably marking a place where the glacier was sitting for a while and was gradually retreating. We also see evidence for ice contact deposits. For example, here, eskers, which are these, this is near Cambus May, but you get some real classic sinuous channels, probably about 10 to 20 meters wide and maybe 2 or 3 meters high, often within wooded terrain, typical of this sort of birchwood terrain near Loch Kinnaird. And these things formed by streams flowing underneath the ice or through the ice. You get sediment deposited at the bottom of them, typically very coarse cobbles and boulders within them. And then as the ice melts, they leave these upstanding ridges behind them. And that's an indication that this terrain was originally overlain by ice. We also see kettle ponds and holes. These are an example near Loch Kinnaird, where basically we've got a glacial outwash terrace here, and you get these really characteristic holes, ponds and holes left in the ground. Those formed where you're close to the edge of the glacier, and you've had ice which has been stranded, dead ice that's stranded beyond the glacier. Then as the outwash plain fills in, it covers them up, but then they melt, leaving these holes behind them, which sometimes fill with water. So they are an indication that this outwash plain was forming close to a glacier front. We have various other bits of evidence for very cold conditions in here. That here's an example, for example, of an ice wedge. They're pretty rare. I've only found one in the terraces that I was looking at. An ice wedge. This is just opposite the golf course at Allerton in the stream there. And what it is it's a place where ice has extruded up through the layered sediments on either side, and then has melted and been replaced by sandy sediment in its place. You also get these sort of polygonal hummocky terrains formed in this area near Nether Mills and Crathes. And these things are essentially relics of what would have been originally ice polygons. So this is places where the permafrost has sort of extruded through the ground, creating this sort of polygonal environments with little ponds between. And that's the sort of thing that would have caused this sort of feature. So I've already mentioned glacial outwash deposits. These are basically the river sediments that formed in front of a glacier. So as the glacier melts, or just as material is brought down through the glacier, the streams that come out of it deposit braided river sandy sediment deposits in front of it. So when you're very close to the front of the glacier, those things have really quite steep dips. I don't know if you can see the colors in here. The choice of colors isn't great. I apologize for that. In this case, the gradient of the slope at this point is about 10 meters per kilometer along the river. And that compares to the normal river gradient of about 3 or 4 meters per kilometer. So significantly steeper than the normal river profile. And the sorts of material that we're looking at in these things are these really rather chaotic, poorly sorted, often quite angular piles of sediment. So that the material hasn't been rounded in by being flowed down the river very far yet. But you're still getting some degree of layering within it. So these are formed in relatively small braided river streams coming through. So this is what's happening close to the glacier. As you move downslope away from the glacier, these things get a little bit more organized, and they make these sort of upper terraces in here with bed forms, sort of channels and bars and things, which are approximately parallel to the river valley itself. These formed essentially within this sort of modern, within a distal outwash plain. So a braided river, but with a glacier somewhere up to the, in this case, in our case, further to the west. And these then have this sort of characteristic. They're bedded sediments of laid down in rivers, typically less than a meter thick beds. You can see a sandier unit here and another one in here. Each one of these is one of these sort of rhythmic pulses of sediment coming down the rivers, but never very thick channels developed within them. And I've mapped all of these terraces from Peter Kuta all the way up to Linn of Dee. And I've characterized them in terms of the different landscape features that they represent. But I've also correlated the individual terraces. And you can see that looking at this green one, for instance, which is essentially the Muir of Dinnet area, and you can follow the river system through here, the old braided river system of the outwash plain through here, and it at its westernmost end, it's sitting about 20 meters above the current river. But by the time it gets down to its more distal end, we're only about 5-7 meters above the current river elevation. And as these things progressively move down slope, they amalgamate into essentially a basal braided river system. But you can see that we've got a series of these stacked river terraces. It's not like they're all once you're a certain height above the river, you're at a certain age. They're actually all stepping backwards towards the west. So they're getting younger as you're going towards the west, as the glacier moved upstream. What you can also see in this profile, which basically shows the elevation of the river all the way from Peter Kuta up to Linn of Dee, is there are a few places where the gradient of the river drops quite considerably. For instance, around Balata, you get a slightly more gentle area there, and a really quite significant reduction in around Braemar. Looking at the one at Braemar first. This is just close to Mar Lodge at the western end, and this would be Invercould, and those outwash terraces that I was describing a little bit early on. Braemar is here, and you've got a number of fan deposits sitting out on top of the valley. The character of the valley changes really quite dramatically from the Invercould area, where you have those different river terraces, the outwash terraces, to the middle of the valley in here, where the whole of the valley is essentially flat. It's a modern meander valley within this system, and there are no terraces left on the slopes on either side at all. So, and what's more, we have a well bore, a borehole drilled near the sewage works at Braemar down in here, which has drilled through about 15 meters of sediment and hasn't hit the bedrock yet. And when you start mapping that up against the position where you get the bedrock coming in at Invercould Bridge, you're considerably lower than the highest position of the bedrock beneath. So it's created this hollow, this basin. So the glacier would have sat in this hollow. I'm speculating about where the base of this is. It could go deeper than this. So that once that glacier had retreated, it would have left a hole, essentially, which would have filled with both water and sediment. The whether or not this actually made a lake really depends on how quickly the sediment filled it after the glacier retreated. But you can see how that the proximal outwash fan, which is this sort of olive green sort of color up here, the highest one of those is sitting probably about 30 to 40 meters above the current level of the river. So that would have marked something like the top of the glacier that would have filled this little basin. There's quite a lot of vertical exaggeration in this picture, but you get the image of what I'm describing here. Get a very similar thing going on in Balata. Here you've got ice contact sediments all the way blocking the valley at this point, and then a big broad basin with very few terraces on either side, and again a well bore which has more sediment in it, about 10 meters, 12 meters of sediment in here, which takes you down to the level of the bedrock at Cambus May. So we haven't hit bedrock in that well bore, and so it'll be below this level somewhere. So again, creating this basin in the valley. Okay, another really interesting feature that's popping out that I wasn't really expecting to see, but I'm sort of recognizing it now, is that some of these terraces that have a sort of surface feature which looks very similar to the normal braided river distal outwash deposits I was discussing earlier. When you actually look at the sediments in the terrace, they're very, very different. Rather than that sort of rhythmic set of layers about a meter thick, the whole section is essentially made up of one big bed. So we're dealing with beds here of about maybe 3-4 meters, which were deposited in one single event. Rather than multiple phases over many years. So this is a single event bed that we're looking at. Some of these units as well, like this one just beneath Camberso-May, I don't know if you can see this LiDAR data is showing some little speckly bits at the top. Each one of those represents a boulder, and that's the sort of size of the boulder that we're looking at in there. So up to about 2 meters in size. That requires, both of these sort of bed forms require very, very high energy, very, very fast moving streams, quite deep streams to actually deposit them. And it's likely that these represent some sort of flood deposit. Whether those are seasonal meltwater floods or actually represent some sort of glacial lake outflow floods, I'm not entirely sure at this stage, but there's certainly very major flood events. We also get these sort of debrite rocks, which are unlike the rock over here, the thick chaotic bed where you have the clasts are all touching each other. In this case, it's the matrix which is supporting the clasts. And that's typical of a debrite, so something that flowed down like a debris flow, like a slump. And this probably represents bank collapse. So again, evidence for a very, very high flood causing local erosion of the banks, and depositing these sorts of debrites within them. So these sort of high energy flood deposits have been described elsewhere in the D, and I'm not the first to describe these things. For example, this is Chest of D here, this is Whitebridge, and this is the Juckelhalp deposit, the glacial lake outburst flood deposit described by Richard Tipping in the Wickham Jones paper of 2020 at Chest of D. Also, Ian Brown in his PhD thesis in 1989, I think, described at Park Quarry, mostly quarried out now, but a flood deposit in that environment. So this is the one that I've identified at Camberso-May. There's another really interesting one here, which seems to be fed from the Louis water, where you've had a flood come down and generate this deposit in here, which is a similar sort of, this almost leaf-shaped fan on the valley floor, and again with very, very coarse boulders within it. It's made up almost entirely of boulders and cobbles. So the sort of environment, the sort of thing that we're talking about, I'm just going to show you a quick, if it actually works. Yeah, that looks like it might. This is from a glacial flood, a Jökulhlaup deposit from an Icelandic glacier in about 2010, I think it was. Just something I found on YouTube, but it gives you an idea of the sorts of energy that can be associated with these flood events. But really high erosive power when it comes down the slope, huge capacity to carry very, very large sediment load and very, very large clasts, and very high flow rates and potential erosion rates of any existing terraces within that part of the system. Just this is just going down the flatter part, but showing the sort of flow rates and the power of these systems. Right, let's see if I can use this one. Good. Okay, so that's the sort of event that we might be talking about. Maybe they are just seasonal flood events, but I think this may be a more powerful than that sort of environment. And something that we should perhaps expect in these sort of mountainous environments where we do have glaciers high up, which will be damming local lakes and which will then burst. So the sort of model that I'm coming up with for describing the features that we're seeing for the glacial sediments, the glacial river terraces, look something like this. You're getting fluctuations in the temperature during that late glacial period. You're getting cold periods where the glacier is essentially standing still and it's developing an outwash plain with a steep dipping proximal outwash plain close to the glacier, which is then flattening out as you run further away. Then you go assume that the temperature warms up slightly and the glacier retreats for a period, and in that period you're going to have the formation potentially of proglacial lakes, and which will be filled by sediments, including delta sediments, proglacial delta sediments. The extent to which this sort of lake formed, they're going to be very ephemeral. They're not going to last very long, and the size of them will depend on how quickly you're actually going to sediment up the system compared to the rate of retreat of the glacier. You're also eroding through the existing outwash plain and that sort of wall that was created by the proximal outwash. And we also this seems to be where we're seeing our flood deposits formed, not on the outwash plain, the proximal outwash plain, but in the valley floor, often associated with an erosional cut through the proximal outwash. Then at some stage later on, you go back into a more cooling phase, and back into a still stand phase, and the whole sequence repeats itself. So you end up with these stacked dipping outwash plains, and that's essentially most of the river terraces that we're seeing in the D. However, at some stage, we change from that sort of pattern of braided river outwash plain into meander terraces. These meander terraces essentially are similar to the river system as it stands now, but that river has been in existence for quite some time, and as it's moved, it's eroded the banks and also deposited new material on the banks themselves as well. So, for example, this is a Boyne airfield in here. This is the upper terrace of a Boyne airfield. And then this is the meander terraces in front of it. And this is a drone photograph showing those meander terraces. So that's the bend in the river that we're seeing over here. You can see would have been the braided river deposit, and then more of the meander terrace sitting in this level in here. And these are made up of bars and channels and you can see how the current river has migrated from a position over here. It's accreted new material on this bank and has been eroding off stuff on the other bank over here. So the sort of material we have in these terraces is basically, it's much more silty and sandy. You still get levels of boulders and cobbles and sands, coarser sands within it, but basically a lot more sand within that system, particularly where we see the channel fill. Here is an example where we've got one of these braided river system being cut through by going into a lower terrace. This lower terrace is full of sand. This material here is where that bank has collapsed down. So that's a typical channel fill, and you're also getting bars within that material. What's quite interesting as well is that within these meander terraces, we're finding an awful lot of charcoal. That we're not finding the charcoal at all within the outwash terraces, the glacial terraces, but in this stuff, it seems to be almost everywhere, which is probably pointing to the fact that certainly there were trees around and there were probably people burning the trees. It doesn't have to be people, I guess, but certainly a lot of charcoal getting into this system. And you can see that pattern of erosion and deposition occurring in the river today. So this process goes on. So I'm sure you're all aware of Storm Frank. You're probably more aware of it than I am, in fact. But these are some images taken around Storm Frank from 2015, where you can see the erosion of the bank cutting out the road near Abergeldy, nearly undercutting the castle itself, doing a lot of damage to Cambus-O'May Bridge, but also inundating the floodplain and allowing a lot of new sedimentation to be occurring within that floodplain. And you can see here the sort of sediment that formed on top of the floodplain. This would have been accumulated over probably hundreds of years of sands and things being dumped every time there was a fresh flood over the top of the floodplain. Here's a nice example from a paper by Feynman in 2020, which is looking at LiDAR data before and after the flood. So before the flood, in this little corner in here, and I think this is just below Dinnet, but I can't remember exactly. But you've got a nice sort of vegetated bar front here. At the end of it, you've lost all that vegetation. You've cut a new channel through the bank here. You've deposited a new bar over in this position, and you've also deposited new material in here. This is the difference between the two LiDAR elevation maps, and you can see deposition here and in here, and then an erosional cut and bank collapse along this edge in here. And this is just a section showing that bank collapse. So that's exactly the same process that I was sort of showing you for the meander near Aboyne Airfield, with the various erosion and deposition on either side. Excuse me. So just how does that fit with the evidence for people living in the Dee? So some of the earliest evidence for people in the area comes from the recognition of material of likely late Upper Paleolithic age around Nether Mills. And this is described as actually sitting on top of one of these braided outwash plain terraces, but sitting right on top of the actual river bar itself, so the braided river system itself, not in the sediments that are sitting on top of it. So probably deposited on an active braided river and one of the bars of the braided river. For the Mesolithic lithics, which are most of what these ones are, they're being deposited on those same terraces, but after they actually had formed terraces. So no longer now part of the braided river system. They're the river terraces forming the banks of the meandering system, which is made up of the yellow and grey coloured material through here. We do have some material in fields walked in these lower meander terraces, but at much lower densities than we see in, for instance, Nether Mills or around Park. And I suspect that these are not in situ. They're either from soil creep down the slope or from floods bringing in material from higher up in the system. So essentially, most of the people were living on those braided river banks, but sitting above the meandering terrace. Just then, excuse me a moment. Then just talking something about the timing of these events. We know that our glacial retreat phase went on through until the beginning of the Windermere, the last glacial interstadial. And it's likely that those glacial outwash deposits and the braided river system continued at least to that point, and I suspect that it continued right through to the end of the Younger Dryas. We normally, one of the drivers for this a change from from a braided system to a meandering system is the effect of vegetation, which tends to stabilize the banks and focus the river flow into discrete channels, which then form our meander system. And at that point, their down cutting rate increases and they'll cut through the existing meander system. We don't see any evidence for an early meander system and then a later Younger Dryas braided system. And the fact that we do seem to have that late Upper Paleolithic material on top of the braided river system does suggest that probably that extended through until the end of the Younger Dryas, and probably the meandering system started as you got the melt water coming in at the end of the Younger Dryas and as the banks started to stabilize during the Holocene and the beginning of the Mesolithic. So just to sort of summarize, I think one of the things I want to emphasize here is that during that late Devonian regional glaciation phase, we're dealing with an extremely dynamic environment. We've got rapid glacial retreat. I was guesstimating about 50 basically it's gone about 100 kilometers in about 5,000 years. So rapid retreat of the glacier. Lots of rapid changes in climate in that period, and a lot of flash flooding, either associated with seasonal meltwater or with glacial lake collapse. Things got better in the Windermere interstadial, but I think we still had our braided river system in that period. We do get an increase in vegetation, but whether we got the same degree of increased vegetation that we see in the earliest Holocene, I'm not sure. During the Younger Dryas, cold conditions returned. We would have had an increase in the seasonal meltwater flow and likely the continuation of the braided river system. And in And then in the earliest Holocene, when you actually got the improvement in the climate and the increase in the vegetation, the beginning of getting trees into the system, that's where you saw the switch from the meandering to the meandering channels. And that sort of pattern continued through the Mesolithic and into the Neolithic and later. In all of these times, you are depositing silts and sands on top of those meandering terraces, but also on top of the braided river systems, just by flooding over the top of the systems. So that question about the timing of the switch, I'm speculating that it's happening at the end of the Younger Dryas. I'm collaborating with a US research team led by Michelle Fame from Amherst College in Massachusetts. Their focus is really in terms of how fluvial geomorphology changes as a response to climate change. They're using a number of different dating techniques to try and date these river terraces. So they're using OSL, beryllium-10 cosmogenic dating, and carbon-14 dating to try and get to the timing of these events. Hopefully these will have some dates later on in 2025, where I was working with them this summer on some of this stuff. And I'm hoping that from that we'll get a better idea about the timing of that switch from the braided to the meandering river system. Okay, and just to finish off, rather than conclusions, it's really some questions, because I think a lot of these ideas still need more confirmation and more work to actually confirm the results. So do our low-level braided terraces correlate with the higher level terraces upstream? I think the LiDAR data supports that really quite strongly. Still a little bit of work to make sure I can correlate those through. And is then that glacial retreat model correct? And also, can we use that then to start to constrain the timing of the glacial retreat? Particularly, I suspect that our geochronological study won't be sufficiently precise to constrain that properly, but we'll see. We're beginning to recognize these flood deposits. How widespread are they? Are they more widespread than I'm recognizing so far? I suspect that they are. I've got a feeling that certainly in the upper part of the D, they might become the dominant part of the terraces in the floodplain. And when did those meander terraces start to form? Was that before or after the Younger Dryas? And the implication of that is, were the late Upper Paleolithic people living on meandering terraces with a relatively constrained river, or were they in an open braided river system at that time? And how does the Dee compare to the Don and other rivers in Grampian? And one of the next things I need to do is to start to look in more detail at the Don and see if I can recognize similar features there. It does seem to be a very different system. We don't seem to have the same amount of glacial outwash sediments associated with that. You seem to go straight from meandering terraces into the glacial till in a lot of cases, without lots and lots of different terraces up the sides of the hills. So there's an old saying, a mile of Don's worth 2 D except it be for fish and tree. Why is that? I think one of the answers to that is the fact that the D is full of this glacial outwash sediment and the flood deposits, which tends to be very coarse material, which is really only good for planting trees. So that's one of the reasons why certainly Upper D side is full of forest. It's because the ground is just full of these really boulder beds, which aren't suitable for cultivation. I think I'll stop there. Thank you very much. Let's stop this. Thank you very much, everyone.
Thank you very much, Simon. That was fascinating. Yeah. Does anybody have any questions? Oh, Sandra's. Yeah, I thought that was a question. But has anybody got any questions they would like to ask Simon or Dan? Do you want? Oh, sorry, Sheila was first. Sheila, go on. You go first.
Hi, I just put it in the chat because it occurred to me as you were talking. If we're looking for evidence of LUP human activity, should we be looking in the subsoil below the present plough soil, topsoil?
I think if we're going to find in situ material, then yes, I think it needs to be not only beneath the plough soil, but it's beneath that sandy cover that would have been put in place during the Holocene, during the Mesolithic, basically. I think a lot of the dating that we have suggests that a lot of that sandy material is quite a lot younger than the braided deposits underneath. So some of it will have worked its way up through, I'm sure, either by ploughing or by other mechanisms, because we are still finding little bits of late Upper Paleolithic material in the plough soil, but it's very, very rare. But I think you're right, we do need to go deeper.
So Graham Warren's team was really interested in the layer into which the Mesolithic pits are cut at Chest of Dee, and they're going to be doing some work on that. And hopefully, if we get this big grant that they're hoping to get, then they will be doing more work on that. But they did take a few samples from that subsoil level, as we would call it. So we'll get some results of that at some point. But
yeah,
Dan?
Yeah, first off, Simon, thank you. Now I understand why I was why I was so confused on some things here. I'm used to a totally different kind of system, and it's a little more like what you're talking about for the Don. First off, one thing that just struck me is you were talking about these flood deposits, and it looks almost as if in at least two cases they could account for some very unusual changes in the current course of the River Dee. If you look in particular, the one at the Park Quarry, one thing I've noticed is the river tends to be fairly straight over its length, except for some places where it takes a radical bend around something. And that looks kind of like it there. I was just kind of curious as to whether you think this, the kind of flood deposit you're describing, and that is a classic debris flow, would be likely to form a bulwark. And if so, do you think these things came in from the side, or do you think they're sequential with, say, maybe, I think there was one at Chemisomé also. Maybe that one was older than the other one. I'm just because I'm thinking that may have affected how the river ran through time.
So Ian Brown described a glacial lake up above the stream that runs into that Park Quarry deposit. I can't remember the name of the stream. And he maps the material in Park Quarry as being this flood deposit. And he describes it as essentially having dammed the Dee at that point. So yes, I think that's very likely. I think some of these deposits, I've got two of them that I've recognized, and I think the one that Richard recognized at Chest of Dee are within the Dee itself and are the result of some sort of localized flood within the Dee. And then I have one that appears to be coming in from the Water of Louis, from a tributary that has flown in from there. And I think there's evidence for a glacial lake perched high on the slopes above above that valley, further up. I might be wrong about exactly which one it is, but it does seem to be a phenomenon that we are seeing. We have evidence for perched lakes high in the Cairngorms. And when those things breached, they would cause this sort of effect.
Well, that leads to the question of, do you have any idea on timing, especially as it relates to the Upper Paleolithic, the Mesolithic, et cetera, et cetera. Do you think they were too
So
early for that, or not?
I think most of this will be during the active deglaciation phase. So
Okay.
before the Windermere. I suspect that once you've lost your glaciers, you'll have a much more stabilized system.
That makes sense. Okay, just wondered. Thank you.
Attila, you've got a question.
Hi, Simon. Thank you for the presentation. I have actually two questions. The first is that you talked about the timing of the deposits with 3 different chronological methods. I just wonder that do you expect to have a sampling for pollen as well with those methodologies to understand?
We're not, and it's very much a geochronology team that we're doing it. It would be very, very interesting. There is existing pollen work that has been done, published from Loch Kinnaird and Morone, I think. There are a few places in the Cairngorms with some pollen data that tell us something about the trees in the area, but it's quite a different set of sediments that you'd be looking for those, and actually trying to find the appropriate sites is very, very hard, as I'm sure people who know more about it here than me can tell you. But we're hoping to start looking at some of that for our MGM stuff as well, but we'll see how we get on with that.
I understand that the grain size is not the best for pollen sampling, but just wonder that if it could be provide the same kind of constraint. The second question is that you mentioned the 2 lakes in the kind of basinal scarps and the 2 boreholes. Just as wonder that if there is a radiocarbon dating or any dating in those.
No, these were commercial sort of geotechnical boreholes. They weren't cored. The descriptions are relatively sketchy, and that we know that it's sand, but there's not enough to tell you anything about the sort of the fine scale stratigraphy, and certainly they weren't looking to be trying to find any carbon within them. And I would be well, it would be interesting to see if we can actually demonstrate that there is evidence from some historical records that there were parts of that Braemar, Loch Braemar, if you like, which continued after into the 1800s, in fact. But whether these were just shallow little lakes within that basin, I'm not entirely sure.
The perspective I'm approaching this was that the presence of these lakes should post-date the big glacial outbursts and the change from the braided river to the meandering river, I assume.
Except I have talked about this with Colin Ballantyne and with Richard Tipping, who are somewhat skeptical about the existence of the lakes. I think what you've got is a rock basin. You can demonstrate that. So if the glacier went away very, very quickly, it would leave a hole that would fill with water. But the question is, how quickly then did it fill with sediments? And given the amount of sediment coming down the river during that late glacial period, it would fill up very quickly. So I don't expect that we'd have a huge, long-lived river lake in that position. Maybe I'm wrong, but I don't think we can justify that as a case.
It's just, again, you mentioned that the topography of that.
Hang on, you've frozen, sorry.
Glacial land deposit.
Sorry, Attila, you froze halfway through that. So can you repeat?
Yeah, unfortunately, sorry for that. So I just, you mentioned that the topography of that lake is very not like that area is very flat compared to the glacial deposits. So
yes,
I thought that it's could be a bit later because it does not fit to that hydrodynamic profile.
I agree. Who knows? It would be quite nice to do some work in that valley and see if there is evidence for a lake, but there isn't any peaty material in that borehole. The trouble is that borehole sits within the fan that comes down from Loch Clooney, from Glen Clooney, and through Braemar itself. Be interesting to see. It's a possibility that there was a longer standing lake there than I've given credit for, but it's difficult to justify. Yeah.
Thanks very much. I've just had a look, and people are saying thanks very much, Simon. Alan says, many thanks, Simon, for such an excellent presentation with superb slides and explanation. I look forward to a chance to looking at it, a record, if and when it's available. So I think I was looking at my screen really closely, and it's actually be quite nice to be able to look back at that. So we will put that up on the YouTube channel, and we'll obviously let everybody know. Are there any other questions?
I was just wondering about the charcoal. You said you found charcoal on the Meander terraces, but not on the braided deposits.
Mm.
And you said that was because there was no trees, basically, so they couldn't make charcoal. Is there definitely no trees at all, or would there just like have been less?
No, he said.
The braided river terrace is not really a great place to stop and have a camp, is it? Because it could be inundated by water any minute, whereas the Meander terrace is a bit more stable, a bit higher, maybe.
I think we certainly haven't observed any, and we were looking for it, basically.
Right.
And we were preparing a lot of surfaces for OSL and cosmogenics, and we would have spotted charcoal coming out in that other material. So it's a bit of a circular argument that you're not finding stuff, and therefore there wasn't any stuff to be found. But I think it's likely that those things are predating the Windermere, and as such, we're not really expecting to have many people in that environment at that time. So it's before the late Upper Paleolithic occupation, during that sort of warmer period before the Younger Dryas. It's actually during the late glacial phase that those sediments are being deposited for the most part.
Yeah, so it'd be really hard to find charcoal if it was there anyway.
Well, yeah. But we've looked. What I was going to do was start doing some sieving, taking some sediment and really try and look very, very hard for micro fragments of charcoal. But I suspect that we won't find any.
Yeah.
Sheila?
Yeah, this is a question. It's not really related to what you were talking about, Simon, but it's something that's I'm curious about. Is there much basalt in Deeside as a stone, a rock that you know of?
There's quite a lot of gabbro, which is a sort of coarse grain basalt, but it's not the same fine grain material. I'm not sure, to be honest. There are various other fine-grained igneous rocks that you might mistake for basalts, if you like. Yeah. And there may well be within that basin. But you also are getting material that's been brought in by glaciers from elsewhere, which might have basalt in it. So can't be certain.
Okay, thank you.
So I'm hedging there, I'm afraid, Sheila. I'm not really sure.
Thank you.
Irvin's got a question.
Yeah, I was just wondering how your work further upstream ties in with Richard Tipping did below Bankery.
I think what I've done here really just confirms what Richard had done. I think there are a few very minor differences. Richard's worked in a lot more detail in a much smaller area.
Yeah.
I was trying to do something on a bit more of a regional scale. And because it's not tied in with the degrees of excavation and augering that he's done, I'm working on exposed river cut outcrops, but I am probably putting in a little bit more of the sedimentology into the story. But I really started with Richard's work as the foundation for it, and his work still stands perfectly well as far as I'm concerned in the lower parts. I think where I might differ is where he's describing things as cane terraces, which would be things that are formed on the sides of the glacier. I'm recognizing those as being outwash terraces. I'm also relating the different levels of terraces, where the stuff that he was publishing basically had all the terraces parallel to each other. I'm now showing that they're backstepping from each other, and they're steeper than the river when they get close to the glacier. So you're affecting getting this chronology as you move further to the west. Yeah. The things get younger to the west. So what would be a high terrace further to the west turns into a low terrace further to the east, if you see what I mean.
Yeah, so they're not the same uniform distance above current water level that you find at low bankery. Yeah. No,
that's right. I think once you're into that sort of the further away from the glacial front, they become a little bit more parallel, but eventually they all merge into that basal braided river surface.
Yeah. Thank you, Simon.
Excellent. Thank you, Simon. I think that's everybody's questions. And somebody's asked about where you will be sharing the YouTube video, and obviously we'll email everybody and let you have the link once it's gone up there. So, but Irvin will chop and tail it for us as he has done before, and I think we might just chop off all the questions. Normally you would just hear the presentation, I think, wouldn't you? And but Simon can decide on that. So thank you very much, Simon. Everybody's
thank you very much for your time and your indulgence for me talking about my pet subject.
That's good. And we will see you all in a field somewhere fairly soon. So thank you very much, everybody. And thanks, Simon.
Great. Thank you very much indeed, everyone.
Bye-bye, everybody.